Hello, in this short video we are going to investigate the following A+ level problem on the topic of the chain rule. Let f be a periodic function with period 4 that is differentiable at every real number. Let g be the function defined on R by this relation. Assuming that f prime of 2 is not equal to 0, the expression g prime of 2 over f prime of 2 is equal to. Pause the video at this point and give it a try to see which one of the following options is the correct answer to this problem. Okay, because the question mark is about derivative of g at point 2 divided by derivative of f at point 2, it motivates us to calculate g prime of x and then replace x with 2. Yes, so let us do that. But of course, be careful here. If I want to differentiate g, I have to use the sum rule here because g is the sum of two functions. But here I have to use the product rule, and within this one I have to choose the chain rule. And then here I also have the product, and for this part I have to use the chain rule. So let us try to do this one first. So I calculate g prime of x. So let me write all these steps. So it becomes the derivative of the first part plus the derivative of the second part. This is just using the sum rule. Okay? But now here, this is the product of two functions, so I use the product rule. So it becomes the derivative of the first one, which is just simply minus 2x, multiplied by the second function itself, but plus the first function itself, which is minus x squared, multiplied by the derivative of this function. Okay, if I give the role of u to this, then I have f of u prime, which according to the chain rule becomes f prime of u times u prime. But u prime in this case will be simply 2x. So what I will do, I would say that this becomes f prime of x squared minus 2 multiplied by the derivative of the inner function, which is in this case 2x. So that is the differentiation of the first part. The differentiation for the second part is a product rule again, because as you see this is a product, so it becomes the derivative of the first one, which is simply 4 multiplied by the second one itself, plus the first one itself, so let me write it here, multiplied by the derivative of the second one. But the derivative of the second one uses the chain rule again by giving the role of u to this as the inner function. So this becomes f prime of u multiplied by u prime, but u prime in this case is simply 4. So it becomes f prime of 4x plus 2 multiplied by an extra 4. So let us write this in a little bit simpler way first. So g prime of x becomes equal to, the first one I just copy and paste. There is nothing I can do here. Sorry, there is no prime here. X squared minus 2. But the next one, I have a 2x here and a minus x squared here, so it becomes minus 2x cubed. And then I have f prime of x squared minus 2. And then the next one, there is nothing I can do, so it is just 4f of 4x plus 2. And for the last one, I can write 4 multiplied by that polynomial 4x plus 2, which becomes 16x plus 8. And then multiplied by f prime of 4x plus 2. There is nothing more I can do here. But you know, in order to answer the question mark, I need to calculate g prime of 2. So this motivates me to replace x with 2. When I replace x with 2 on the left, I have to replace all x's on the right with 2. So this means that this becomes g prime of 2 is equal to. So I replace x with 2, so this becomes minus 4, this becomes 4 minus 2, 2. So it becomes minus 4 f of 2. The next one, this becomes 8 times minus 2 is minus 16, and then I will have f prime of 2 again. But here, if I replace x with 2, so this becomes 8 plus 2, 10, so it becomes 4f of 10. Okay, and then if I replace x with 2 here, so this becomes 32 plus 8, which is 40, and then f prime of 10. So this is g prime of 2. But now look, if I want to calculate the question mark, I have to calculate g prime of 2 divided by f prime of 2. So this motivates me to divide the left-hand side and the right-hand side by f prime of 2. So the left-hand side simply becomes my question mark, which is g prime of 2 over f prime of 2. But there are 1, 2, 3, 4 terms on the right, so I have to divide all of them by f prime of 2. So let us see what happens. So here, up to here, I haven't been creative at all. I'm just following the standard rules, yes? So it becomes f of 2 divided by f prime of 2 minus 16 f prime of 2 divided by f prime of 2. This one is of course simple. And then the next one is 4f of 2 divided by f prime of 2. And finally I have 40 f prime of 10 divided by f prime of 2. Okay, so this one, as I told you, this one and that one are simplified, so here I have only 16 left. But what about the other ones? Okay, remember, so far I haven't used the fact that the function f is periodic with period 4. So what does it mean? When you say that the function f is periodic with period 4, it means for all choices of x, f of x plus 4 is equal to f of x itself. Yes, because the function is periodic with period 4, that is exactly the definition of a function being periodic with period 4. But then, one thing that happens, if I differentiate both sides, so this becomes f of x plus 4 derivative, because this relation is valid for all x's, I can differentiate both, and because the function f is differentiable everywhere, so I don't need to be worried if the derivative exists or not. So the right-hand side becomes f of x prime. But the left-hand side is just a chain rule, which gives me f prime of x plus 4, but multiplied by the derivative of the inner function, but the derivative of the inner function here is 1. And this one is just simply f prime of x. So what does this mean? This means that if your original function f is periodic with period 4, the derivative remains periodic with period 4. Okay, because again, f prime of x plus 4 goes back to f prime of x itself. Okay. And what is the meaning of being periodic with period 4? It means that if you add any integer multiple of the period 4 to x, the function remains the same. Okay? And the same thing for f prime. So let us see what we need. First of all, I need to compare f prime of 10 and f prime of 2. My claim is that they are equal. Why? Because f prime of 10 can be written as f prime of 2 plus 2 times 4. So what is happening? In order to calculate f prime of 10, I write 10 in this form, but this is 2 times the period 4, because the derivative is also periodic with period 4. So this means that this can be eliminated because that is an integer multiple of the period. So this becomes exactly f prime of 2. So this means that f prime of 10 and f prime of 2 are also equal. So when they are equal, what I can do, I can also simplify them. So this number is just 40. And now if you see what is happening here, they are just simply equal. So they are gone. Yes? So this means that this expression and that expression are simplified, because one of them is minus 4 f of 2 f prime of 2, the other one is plus f of 2 f prime of 2. So what is left for the question mark finally is this. The question mark is equal to minus 16 plus 40. So the answer becomes 24. So So the answer to this question mark is 24. So this means that the answer is part C. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.